Today, we're going to talk about ratios. We use ratios to compare quantities in mathematics. We are in chapter 6 of Singapore Math textbook, page 149. So sometimes we do need to compare, in this case, look at the pictures, blue ink and red ink, blue pens to red pens. And there is a certain way in mathematics we can write this comparison. For example, we had David and John visited art supply store. David bought 3 bottles of blue ink and 2 bottles of red ink. We say the ratio of the number of bottles of blue to the number of bottles of red is 3 to 2. And you can see it based on the picture. We write ratios in the language of mathematics using the colon to represent the 2, T-O. Look at the next example. John bought 5 boxes of blue pens and 2 boxes of red pens. Again, it's very pictorial, very easy at first to understand. We have 5 boxes of blue, 2 boxes of red. We can say the ratio of blue to red pens is 5 to 2. Or we would write it in language of math as 5 to 2. And we use this semicolon for the word to in English. You know how in language of math, most English words have an equivalent representation. So the word to is a colon, which is, by the way, also a division sign, as you all know, and there is a connection. Next, Ricardo mixed 3 cans of red paint with 1 can of white paint. So we have 3 cans of red and 1 can of white. Probably he's trying to mix some shade of light red or maybe pink color. The ratio of the number of red to the number of white paint is 3 to 1. I also at first like to just label what I am comparing. In this example, I'm comparing red to white, so it is 3 to 1. The order matters. Next, so we would write the number of cans of white paint to the cans of red paint. Now we want white to red, and we would, of course, put numbers accordingly, 1 to 3. My friends, red to white and white to red are not the same. Order matters. So when we are comparing white to red, the number of cans for white paint goes first. Let's take a look at the jam. Let's take a look at the jam example. The ratio of the number of jars of jam to the number of jars of jelly is 3 to 2. And we can see, even though there are many more smaller individual jars and cans, we see how they're grouped into boxes. So the number of the ratio, we say the ratio of the number of jars of jam to jelly, I like to label it first, is 3 to 2. The ratio of the number of jelly to the jars of jam, so now it's jelly to jam. And of course, we put the numbers accordingly. There were 2 cartons of jelly jars and 3 cartons of jam. So it's 2 to 3. Again, the order matters. Notice what we got above. 3 to 2 of jam to jelly is not the same as 2 to 3 of jelly to jam. And of course, we do have other examples of strawberry and chocolate milk. Let's take a look at groups of objects. These are groups of objects, right? We already saw jars grouped together. The ratio of the number of buckets to the number of shovels, again, I like to label it at first, buckets to shovels is 3 to 2. Now, I hope you hear and you see the resemblance to what we've done in our work of fractions, about fractions. Ratios and fractions are very much related. We will see it in a later video. Now, let's take a look at maybe it's a number P or a string P and a string Q. We have 3 units of P and 1, 2, 3, 4, 5, 6, 7 units of Q. The ratio of the length of P, I'm putting it on top, to Q is 3 to 7. Again, notice how I label my sides at first because it is important. The order is important. Reversing it would be a mistake. Problem number 6, the ratio of length of the rectangle to width. Again, I'm putting length to width. Why? Because that's what they're asking. Let's count the length. 1, 2, 3, 4, 5. Length equals to 5. And of course, we can see that width equals to 4. The ratio of length to width is 5 to 4. If they were to ask for the ratio of width to length, we would reverse the numbers and say 4 to 5. Now, example 7. We have 2 jars, and they're both little beakers of 1 liter capacity. We have different values. The ratio, again, let me underline this word. We're looking for ratios. The ratio, the ratio, the ratio, right? That's the new language we're learning today. The ratio of the volume of sand in container X to the volume of sand in container Y, again, X to Y is 1, 2, 3, 4. It's 400 milliliters, and 1, 2, 3, 4, 5, 6, 600 milliliters. So we would say 400 to 600. Again, we use ratios to compare two quantities. We can also compare more, as we will see in the next video. Example number 8. The ratio of the number of cubes in solid A to the number of cubes in solid B. Again, they're asking for the ratio of A to B, and we have 3 cubes in the volume for A, and we have 8 cubes for the volume of cube B. Again, pay attention to the order. It is always given in the problem. Example 9, final example. The ratio of the mass of package C to the mass of package D. I'm going to label my ratio. They want C to D. That's the order of comparison. Let's take a look. This is in kilograms, right? We see the labels, and we have 1, 2, 3, 4, 5 kilograms. This package weighs 5 kilograms, and the next package D weighs 7 kilograms. We would simply say, if we compare C to D, the ratio of their mass is 5 to 7. I hope you found this basic introduction to ratios useful, and if you have any questions, you can look at the following video.